What's up, guys? So today we have a package in the mail from a viewer. This is a mod attempt on a Nintendo Switch. I think they've successfully modded OLEDs in the past, but this one just has some trace damage that they were unable to fix. So we're gonna see how bad the damage is. See if we can't get this thing to boot again. Cool, so we got some customer information. I got a little note here, and they're just saying they put it in a donor shell just to keep it safe with minimal screws. All right, and there's no screen protector on this, so I am gonna put down just a bit of this felt paper, kind of protect it a bit. Got no SD card, but yeah, let's see what we got. So since we know there's been work on this in the past, probably won't boot it or attempt to boot it yet. It's gonna get a nice physical inspection of the board. Okay, so they don't have a shield on here, but they do have the battery plugged in, so I will unplug. Well, with the battery plugged in, let's just measure voltage. So we're gonna go to DC volts, black on ground. We got only 2.5 volts on the battery, so I think either the battery's dead or something's pulling the main power rail down. Let's see what voltage we have with the battery unplugged. Yeah, 2.5 volts. So this battery's just kind of drained. So unplug this. So we've got the screen plugged in. Yeah, everything's plugged in. We can take a few measurements just to see how things are looking. So I'm just gonna grab resistance on the main power rail. All right, that looks pretty standard. Get this thing off of here. With any luck, there's no thermal paste. God bless, I hate thermal paste. All right, so they already took that off. Just clean it up a little bit more here. And we can kind of touch up the shield here a little bit. All right, this shield is a little bit bent, but I've seen much worse. This is not too bad. I know they bent this out in order to get out of the way of the sort of trace repair work they already attempted here. So this is where I actually wanted these mini pliers, because we can bend these in the other way. So I'm gonna bend these in the way I normally do, which is in instead of out. Just makes for a cleaner looking shield. All right, so I just went ahead and folded all those in instead of out, and we can kind of correct some of these locks here because they're a bit bent. Cool, it's looking good. Let's zoom in and take a look. So far, just doing sort of a visual inspection here. Nothing looks too bad. It does look like they did originally have the adapter on here, because you can see the solder points for the ground connection and then some peaks on the cap on the left there. So let me just get this area cleaned up with some alcohol. And here is where we've got some issues. So I think the story is some traces were scraped here when either pulling off the APU shield or cutting and bending away this thing here. So I'm not too sure, but yeah, it looks like we have a torn trace, and they soldered from the via over there down to the sort of exposed area of the trace. And this actually doesn't look too horrible in terms of like what they attempted to do. For now, I'm just gonna unsolder from here and unsolder from here, and I'll try to scrape away at some of this existing solder mask there to sort of get a bit of a better view as to what's going on. My thought process here already is that if this isn't working, then it looks like this trace may be fully severed from here to here, which is more of what we would want to repair instead of connecting the via to here. It might be good to look at a donor actually, just to get an idea of what's what. All right, so here's a donor board. Excuse the mess. It's kind of nasty board right now. You can see all of these traces here just go straight through the APU. That's what I thought. So there's no vias at the bottom there. So my thought process is, I think this here is severed, this trace. Yeah, okay. It appears as though there is no via there. I think they thought there was a via or something, as far as I remember from the email conversation I had with them. But maybe they were talking about the via up here. So let's try that. Let me just remove this from here. Oh, okay. Oh, that via is still intact. Yeah, so we're fine there. So there actually isn't a need for a wire here at all, because that's still going where it should. It's just severed here like I thought it would be. So it looks like potentially they tried to solder from here to the via. I see what they're doing, which actually could cause problems, because this is a data line, and if you replace this with like a shorter line, timings can be off, which is why you actually see squiggles sometimes on data lines like this. You might wonder, why on earth would you squiggle this line like up and down like this, and why wouldn't you just go straight to the point? And the reason for this is to length match, or to have a specific length on here so that the data gets from point A to point B at the same time as the clock signal, for example, or other data lines. So this is a pretty common technique to make sure the lines are exactly the same length, because the length of traces at this scale, when you start talking about like super high frequency data and clock signals, believe it or not, the length of the traces actually does matter. So in other words, this thicker and potentially shorter or longer wire than the trace is here might be causing issues even if it was making connection between here and the via. But yeah, really we want to connect this here and just repair this area, and probably we can just get rid of this wire. Yeah, it looks like this should come out fine. There we go, the whole thing came off. So I'm gonna get rid of that. It's not really hurting anyone there, so I might just leave that, to be honest. But what we can do is just try to clean up the area a little bit better. There we go. And normally with traces this small, I wouldn't use a grinding pen, but I am going to use a grinding pen in this case because there's some solder mask here above where we would potentially want to solder to. All right, that's plenty. I did go through the trace above it, but that's fine. We'll just throw some mask over it anyways after. You can see why I don't generally like using grinding pen for traces that small. The tip on my pen is also not like the smallest. But yeah, that's not a problem there. We can just cover that up. We just need to solder to the one above there. So let's dry this off. Also just sort of like try to scrape a little bit of the excess off here. That is perfect. So what we want to do is tin the trace right there. And just to make our lives a little easier, I'll put solder mask right away on those traces I scraped a bit above. All right, so we'll just throw some solder mask there. Let me get that cured. All right, so let me get this cleaned, and we can use some flux here. It looks like they already did a little bit of our job here for us to tin the bottom one, but we just still have to tin the top one. So this sort of trace repair work is where I like to use the bent conical tip like this instead of the knife tip. Just a bit more precise, easier to work with on small traces like this. So generally you kind of have to scrape a little bit to get solder to start sticking. Then we can try to come in here and add solder to it like that. And I'll just go over this bottom one again, get it cleaned up a bit. That's looking nice. Now I'm going to use some really thin wire here. And with this sort of stuff, angles really help a ton to make your life easy. So I'm going to turn this around. And before I do anything, I'm just going to try to burn the enamel off of a piece of this wire. And I want to burn it off on like the whole length, just like this. Since it's such a short thing, the whole wire can be tinned for all I care. If it was going any farther, I would definitely just tin the two ends, but we're going to be covering this whole thing up in mask anyways. So we want something pretty short. And then what we got to do here is just hold it in place with the tweezers, get it soldered down to both sides. Just like that. And we can kind of bend this to see where it connects. I don't want to bend it too much. Should really use the ceramic scissors just to snip that and straighten it out a little bit. Good stuff. So I'm happy with this. Let me just like clean it up a little bit with some alcohol. Gotta be pretty delicate in this area, so I'm using a soft brush and then just some hot air to like liquefy the flux. Then we can try to soak up some of the liquefied flux that's mixed in with alcohol. Cool. And we want it dry just like that. Okay, so that's looking pretty good now. We can just try to poke this a little bit, make sure it's soldered on either side, and it is. So that's looking good. I'll just do a quick physical inspection and then we'll try to boot this thing and see if it works. Display connector looks properly seated. Does look a little bit damaged on the corner here. You can see a bit of damage here, or it's actually melted there. But fortunately, I don't think this is actually used for anything unless this connects through this via here to the other side, to the bottom. So we might actually have to repair this display flex cable, but we'll see. We've got these 3-volt caps bridged on either side, but that doesn't matter because they're the same trace. This is ground, this is the 3.3 volt rail, so that's not going to cause issues. The A resistor here we can check. Let's check with resistance mode. This is a 4.7 k ohm resistor, but I know the resistance reading will read a little bit lower in circuit just from experience, but it shouldn't read too low. That's a good reading right there, 3.3. I always check this because this is very sensitive to heat. It's very easy to burn during a chip installation. And if that burns, then the console won't boot. We get a purple screen without that resistor there. So if you see a really out there resistance reading on that, you'll know you'll have to replace that. And even being careful, I've burnt that resistor before, to be honest. It really doesn't take a lot of heat. If you just sit on it a little too long with your iron, it's done. And that's a small component, so it kind of makes sense. It's super, super small. Don't be fooled by the microscope over here. It's tiny, tiny, tiny. We can also double check this via. This is actually probably, wow, okay. Shout out to the person who did this. This is probably the best job I've seen on this point here where you have to scrape it back. Almost every other console I get that is a mod attempt, this is like really in rough shape. So nice job to the viewer who sent this in. Impressive work there. And also a really solid trace repair attempt here. Like, this is really tiny. I don't know how else to sort of demonstrate. Maybe I can show you. Here's my pinky. So just to give you an idea of how small this is. This is really small to work on. So the work that the viewer sent in is actually really solid attempt there at repairing that trace, and wasn't bridging other stuff as far as I could see. So, all right, so just for fun, we can test the resistance on caps here just to see. Should be about 10 ohms. Yep, 13 ohms. Ooh, okay. That one reads pretty low resistance. Let me try that again. Yeah, that's reading about half an ohm. I don't think that should be that low. So we might actually have a shorted APU here, unfortunately. And yeah, that's really low. You can see we've got 300 milliohms up there. That's about 0.35 of an ohm, which is not good. It should be a lot more like this, 14 ohms. That makes sense. It should still be a low resistance, but that is looking like a shorted APU to me, unless there's some like solder bridge here that we don't see, or unless there is a short here. Maybe that's one of the points here shorting somehow to ground. Let's check. We can check resistance to ground on this wire here. No, that's reading almost a mega ohm, so that's not gonna be it. Yeah, I don't have too much hope for that, and I don't see any like shorts with solder here right now. Yeah, I don't know about that. That looks kind of suspicious, that resistance reading, so I'm hoping that we don't have a shorted APU, but I think we might. I'll still give this a shot after doing the trace repair there, but it's unlikely that this is going to work. So I think this has a charge. Let's see how we're looking. Yeah, 3.8 volts almost. Definitely charged sufficiently. So let's plug this in. We've got 3.8. Let's measure with the charged battery here. On the main power rail, we have 3.8. So let's see when I press power here if we get anything on the screen. Yeah, nothing. Not surprised with a short on the APU like that. All right, so let's actually unplug the battery here, and then I'll just plug in the battery again without hitting power. And let's take a look under the thermal camera what we have. All right, so we've got the thermal camera here. Let's try turning it on, pressing power, and I'm not seeing any. Whoa, you can see something heating up a ton on the display thing there. Whoa, that's like on the display adapter or below it or something. I just turned off the console. All right, before we turn this on again, let's look under the microscope at this connector here. The heat was like coming from right here. I turned it upside down just now. I don't know if that's because of what we just saw there, the melted connector there. So let's just pull this out. We can look at it on the other side too. Yeah, so I'm not too sure. I think our short was definitely on display connector here. I'm not too sure. That's really strange. Or it's on the other side of the board, but I think it looked like it was on this side. So let's see actually with that disconnected, what kind of resistance we have on that same capacitor on the APU, because maybe that was all it was. Whoa, 3.3 kilo ohms. So did that resolve our short? I think that resolved our short on the APU. We won't get display, but we'll actually be able to see if it boots using the thermal camera. Guys, I'm telling you, a thermal camera is like you can already see here, just seeing where the short was on the display connector. Sorry, I'm just realizing I didn't switch to the thermal cam view, but I was seeing right here like a super bright spot on the display connector. To avoid damaging the console, I'm not going to plug this back in to show you, but there was, trust me, like right here, right where we saw the melted connector, heat coming from there. And if we plug this in now with the battery, we can also use the thermal camera, I'll actually show it to you this time, to see if the console's booting, because we'll see heat on the APU, but also on the memory chips here. So I'm going to press power, and you can see, there we go, the console I think is booting now. Yeah, this thing's definitely booting. You can see the heat on the APU and some heat on the memory chips here. So I'm pretty sure this thing is on now. I'm gonna pull power. We also have a little bit of a crease on the display connector as well. And I'm wondering if we don't have some pins potentially like bent in the connector, the display connector. So let me get this board out of here. We'll take a visual inspection of the port itself. All right, so I got the board out here, and let's just take a look in the display thing here, because I think I see on this flex cable here, you see that like bend in the display cable. And this is a pretty common thing that can happen when putting the console back together, is you can bend the pins inside easily, and you can see how the actual flex cable is bent. I think that's actually what was causing the short. It might not even be related to the melted flex cable there. So that's more of my guess, is that the bend here in the flex probably caused some pins in here to bend. So let's see if that's actually the case or not. So here's the, oh yeah, I can already see it. Can you guys see it? So you can see the one pin in there that's just sort of like mangled. Let me try to turn this the other way around So here's the display connector, and on the right there, you can see one of those pins is bent. It's very unlikely we're going to be able to bend that back. This thing is super small. We can give it a shot, but I've only been successful in doing this like once or twice, just because usually it just makes more sense to replace the port because of how bent these pins are. So there's the pin there, and it belongs over here. We might actually be able to do it this one. So just gotta bend it a little bit more over to the left there and then up. You can see the slot it goes in that's empty right here. I'll do what I can. Okay, so not only is this thing bent, but you can see it's also twisted. So you can see this part has to go up into here like these other ones, but unfortunately it's twisted and bent. So if it was just bent, we might be able to just like bend it back and up, but I think it's gonna be a bit of a bitch to get that back. And we'll probably spend more time just doing that than putting a new connector on, to be honest. But I'll give it a shot here. Apologies for the shaky. It's not the camera that's shaky, it's my hands holding this board. Yeah, I don't think I'm gonna be able to get this thing back in. I mean, the other thing we could try is, it might be redundant, so we might be able to just like bend it back and forth to break it off and take it out fully. That actually might work if it's a redundant pin, but if it's like a data pin and it's like the only one, then that's not gonna work. And I'm glad I didn't try to just plug this into a new display without looking at the port, because it would have just ruined the other display flex, or at least bent it up nicely like it did with this one. So I think the move here is to potentially try to bend this enough to take it off. Actually, you know what? I have an idea. Just to give this one more go by just potentially either bending that pin back or breaking it off. Let me go get a board holder that I basically never use. So here's the board holder. I hate this thing. It's completely useless 99% of the time. But for vertical stuff, this comes in handy. So there's our pin. My thought process is to just like grab it. Actually, maybe if I grab it hard enough, it will. Oh my God, did I just unbend it? Look at that. I'm gonna twist it a little bit. Whoa, I untwisted it. I did not think I was gonna be able to do that. This may be savable. Okay, it broke off. I'm actually happy about that. That was gonna be plan B. So it broke off. Let's just get it out of there. I think twisting it was its last straw. So there it is. F in chat for the pin. And now we can see it's just kind of missing, which is better than shorting, right? Again, it is totally possible that that pin is redundant with like another one next to it, or maybe even more than one next to it. So what we'll do is we'll actually plug this back into the same display. I will have to try to flatten out this flex cable because it's kind of bent up a bit because of that pin, and I don't want it to ruin the connector more. All right, I think I've largely unbent the flex. I just sort of like dragged over the bent area. You can see the discoloration. That's just from me scraping the pads. I think I've successfully made this thing straight. So I'm gonna very gently try to insert this display flex cable. Okay, I think that actually went in without any sort of like friction as far as I could tell, or too much friction. And before I go crazy with putting this back in, let's just measure resistance on that cap again and see if that's shorted again. Nope, not shorted anymore, even with the display plugged in. So what do you guys think? Think this is gonna work? That would be cool. So I always like to screw in this screw at least so that you don't like bend this thin part when you're unplugging the battery connector. So I'm gonna do that, and I'm also gonna throw in just this other screw here. We don't need the Joy-Con rails plugged in to test. I will actually plug the speakers in because it's possible the panel won't work, but the digitizer will, in which case we'll be able to hear the switch through the speakers. So I'm gonna plug the speakers in. And we also obviously want to plug in the power button and the volume buttons so we can test if the console is working even if the display isn't working. Oh, it also looks like the battery connector might be coming up a bit, so I'm gonna try to be more gentle with that. Battery connector looks a little bit finicky. All right, let's turn it on. Let's see what happens if we get anything. Whoa, look at that. So this doesn't mean it's functional right now. There may still be issues with like the digitizer or something. Ah, look at that. I think this thing's working. Yep, sound works. Crazy. So let me get this thing reassembled, and we're gonna do some tests just to make sure the whole thing works, but this is a pretty W repair. But again, we'll have to see, we'll have to fully test the display and make sure the whole thing works, not just like parts of the digitizer, make sure brightness, all that stuff. And if everything works display wise, I'm gonna call this thing a fix. I know for a fact a lot of times on connectors like this or on chips, you'll have more than one pin that are the same point. Anyways, let me get this thing fully put back together. We'll get this battery charged up. I'll put it back the way it came, at least with some thermal paste on it, and then we'll go from there. Before we get this thing reassembled, actually, let's put some solder mask on the repaired area here. Sorry, not here, over here. Yeah, let's just get this trace insulated. All right, I'll cure this. Cool, so that is looking much better. I also want to take a look at the battery connector over here. This thing kind of seems to be pulling up a little bit, so I'll just add a little bit of the UV resin to the edges of that quickly, because that'll just add some extra support. So we'll just come in here and just kind of throw it around the edges. We don't want to put this stuff on too thick because it can inhibit the battery from connecting fully. But there we go. I'm just gonna cure this with the UV light. I'll just put a little bit more around the other corner here. Just trying to get this thing as fixed up as I can. I'm really liking this UV resin for jobs like this where we really want like more structural support on a connector. It works wonders. And also like holding down wires on a PCB. Also outside of it providing more structural support than solder mask, it cures much better because it's clear. You can also get clear solder mask, which I've heard is nice as well. So now I'll just get this thing reassembled with some thermal paste. Before I get this thing fully closed out, let me just double check this thing is taking a charge. Yep, 15 volts. Okay, it's strung under 100 milliamps now. It's probably because the battery is so drained. We can always measure the voltage and make sure it's sort of like climbing slowly. This is a nice trick to see if the battery's charging. You just put red on red, black on black while it's charging. And you can see the voltage is slowly climbing up on the top left there, 2.72. It's gonna be at 2.73 soon. So yeah, this thing is charging. It's just charging really slow. This can happen when the battery is like super dead and hasn't been charged in a long time. It's gonna draw like a really low current. Oh, we have a battery symbol on the switch there as well. Once the battery gets over certain voltage, it's gonna jump up to fast charge. This is just how it sort of behaves when the battery is like extremely dead. So let's just give it some time. Cool, so you can see it jumped up to 400 milliamps now. So it's taking quite a lot more power and it's still charging. So it's not like the console is taking that to boot. So all of that current is going into the battery. So I'm happy enough with this. I'm just gonna get the back put on here and I'll continue to charge the console and we'll do some testing. It's just another great example of why a thermal camera is just like a non-optional tool for me. The amount of time that just saves me to like zero in on what the problem was. It was the display port. I don't know how much time I would have spent like messing around with this. It would have been really easy to accidentally just write this off as a dead APU with the short on the APU there. So just another reason to get a thermal camera. All right, this thing turned on now. So got display, grayscale, invert colors, just to see. We've got vivid, standard. We could try the screen brightness here. That looks fine to me. Auto brightness off. You can't see, but that looks completely fine to me. It's just really bright. And then let's do test input, test the touchscreen, and let's just see. This thing is looking like it is fully functional to me. Yeah, look at that. Can't see that super well, but there you go. You can see this thing is like detecting all of the areas on the screen here. Yeah, so the screen is fully functional and we've got a working console. So I'm gonna go ahead and let the customer know that it's a fix. Again, that thermal camera is insane, zeroing in on things at times. So I'm really happy with this fix. I appreciate you guys for watching and I will see you in the next video. Peace.